Today, we're diving into a piece of software that is completely changing how we build, well, everything, from massive skyscrapers to complex power plants. It's called Autodesk Navisworks, and the whole thing really boils down to one simple but incredibly powerful idea. No, seriously, just think about that for a second. What if you could build an entire, complicated building from the ground up and then get a do-over? A chance to build it again, but this time, perfectly. And that's the secret right there. The first build happens entirely inside a computer. It's like a full dress rehearsal in the digital world, where you can find, flag, and fix every single mistake before 1 cent is spent on actual materials or labor. Now, to really get why this is such a game changer, you have to understand a massive problem that's always plagued the construction industry. Look, modern construction projects are just mind-bogglingly complex. You've got these brilliant teams of architects, structural engineers, mechanical engineers, plumbers, electricians. I mean, all of them are experts, right? But the problem has always been that they're often working in their own little worlds, in their own silos, creating a huge disconnect. And this is that hidden crisis. When all these separate plans finally meet in the real world, they crash into each other, literally. Imagine the structural engineer designs a huge steel beam, and at the exact same time, the HVAC engineer designs a giant air duct to run through that exact same space. On paper, in their separate files, it all looks fine. But out on the job site, you've got two solid objects trying to defy the laws of physics. That's a clash, and fixing it in the real world costs an absolute fortune. So the industry knew it needed a new philosophy. And that philosophy is Building Information Modeling, or BIM. Now, it's really important to get this. BIM isn't a piece of software. It's a whole new way of working. It's about getting every single person, from the architect to the contractor, to work together on one single, unified digital model of the entire project. But, a philosophy is just an idea. To make it work, you need a place for it to actually happen. You need a digital arena, a proving ground, where all these different plans can finally come together and be tested against each other. And that digital proving ground is Autodesk Navisworks. This is the software that acts as that central hub. It's built for one main purpose: to take all those separate, incredibly detailed 3D models from all the different teams and merge them into one single project so everybody can finally see the big picture. And this is where we get to Navisworks' real superpower: model aggregation. Honestly, the best way to think about it is like a universal translator for design software. It can take files from all these different programs, Revit from the architects, AutoCAD from the drafters, Civil 3D from the site planners, and it just stitches them all together. It doesn't care what language the model was written in. Navisworks brings everyone into the same room for the same conversation. Okay, so you've brought all these different models together into one giant master file. So what? Well, this is where the real magic happens. This is where you go hunting for all those expensive problems we were just talking about. I absolutely love this analogy because it's just perfect, right? Before you publish an important document, you run a spell checker to catch all the typos. Well, Navisworks does the exact same thing, but for a multi-million-dollar building. It automatically scans the entire project to find every single place where things just don't fit together. And here's how that spell check actually works. First, you set up the rules. You basically tell Navisworks, hey, check all of the plumbing pipes against all of the structural beams. Then the software just goes to work, churning through the whole model and flagging every single conflict. Finally, the teams get a report of every clash, they can see it in 3D, and they can solve it right then and there, digitally, long before it becomes a real-world headache. And the software is smart, too. It doesn't just find one kind of problem. You've got your hard clashes. That's the obvious stuff, right? A pipe trying to run straight through a solid concrete column. But then you have soft clashes, which are more subtle but just as critical. This is where something doesn't have the required space around it. The classic example is an electrical panel that's installed too close to a wall, so you can't actually open the door to service it. It's not hitting anything, but it's still a huge design flaw. Okay, so just finding clashes in 3D is already revolutionary, but Navisworks takes it to a whole other level. It introduces a fourth dimension. So what on earth is the fourth dimension when you're talking about a building? It's time. It's the project schedule. 4D simulation is what happens when you link every single component in your 3D model to a specific task on the construction timeline. So you can literally hit play and watch the entire building get built right on your screen over time. You see the foundation get poured in month 1, the steel frame goes up in month 3, and so on. It's like watching a time-lapse video of your project before you've even broken ground. And this is so incredibly powerful because now you're not just finding clashes in space, you're finding clashes in time. You can spot logistical nightmares months in advance. The simulation might show you that the drywall team is scheduled to show up before the electricians have even finished running wires in the walls. That's a massive sequencing problem that you can now see and fix with a few clicks. So, as you can probably tell, the potential here is just enormous. But like with any powerful tool, using it in the real world comes with some huge benefits, but also a few hurdles you've got to clear. The payoff is pretty clear. When you catch these mistakes early, you're saving a ton of money on rework that just destroys budgets. You're forcing teams to actually talk to each other and solve problems collaboratively instead of pointing fingers on a muddy job site. And maybe best of all, you give everyone from the client to the project manager this crystal clear vision of the final product, which just leads to way smarter and faster decisions. But look, it's not a magic wand. There are some real-world challenges. Just making sure every single team is using a compatible version of their software can be a huge headache. The review process itself, going through thousands of potential clashes, takes a lot of dedicated time. And these combined models can get absolutely massive. We're talking huge file sizes that need some serious computing power to manage. But at the end of the day, even with those hurdles, the value is just undeniable. The whole idea is simple. By finding and fixing problems in the digital world, you prevent them from costing you a fortune in the real world. It's all about stopping those conflicts before they happen to keep projects on track and on budget. It really makes you wonder, though, what comes next? I mean, we're getting so good at this digital rehearsal, at building things perfectly in the computer first. So if we can solve clashes in space and time before they even happen, what other kinds of problems can we start to predict and prevent? That, right there, is the exciting new frontier this technology is blowing wide